All right. Before we talk about dividing by 0, I'm going to convince you of the following thing. I'm going to convince you that 2 and 1 are the same number. So, here is my theorem, that 2 equals 1. So, anytime I give you a result, I have to tell you why it's true. So we're going to do a little proof. So, I'm just going to let A and B be whatever counting numbers I want. But I'm going to make it kind of very specific. It's kind of ridiculous. Just go along with it. Where A is B. So, I'm going to show you that 2 equals 1 by just picking A and B such that they're the same number. So, let's consider A equals B. We picked them that way. We know that's true. Okay? What I'm going to do next is I am going to multiply both sides by A. So if I do that, A times A, well, that's A multiplied by itself twice. That's A squared equals A times B. Okay? The next thing I'm going to do is I'm going to subtract B squared from both sides. I can do that, no problem. Whatever I do to one side, I can do to the other, pretty much. So we get A squared minus B squared equals AB minus B squared. Okay? Everything looks good so far. The next thing I'm going to do is I'm going to factor both sides. We're going to talk about the left-hand side a little bit. This is called the difference of two squares. If you took a pre-calculus course, this probably looks very familiar to you. If not, well, let me convince you of something. If I take A plus B and I multiply it by A minus B, you guys can check. Maybe it's a good idea. Pause the video now. Do this little multiplication. A plus B times A minus B. See what you get. Now that you're back, you should see what's happening here. The first gives us A squared. Second gives us negative AB. Then we have positive AB. Then we have minus B squared. So these guys cancel, and we're left with A squared minus B squared. So I'm going to factor that out. I'm going to factor A squared minus B squared as A plus B times A minus B. Because, hey, look, they equal. We just worked it out. And over here I see a common factor of B. I'm going to factor that out. So this becomes A plus B times A minus B. And this becomes A minus B times B. We'll write it like that. So no problem so far. You can see everything is good. Well, the next thing I'm going to do is I'm going to cancel out this A minus B. I see a factor of A minus B on both sides, so I'm going to cancel that out. And now I get A plus B equals B. Okay. But remember that, hey, look, A equals B. So I'm going to use that fact again, that A equals B. Since A equals B, I'm going to replace A by B. So this is the same thing as B plus B, or 2B equals B, since, remember, here we have since A equals B. And then we're just going to divide both sides by B. Well, and remember, B is a counting number. It's not going to be 0, so we can divide by B, no problem. So 2B divided by B is just 2, and B divided by B is 1. So hey, look, I just proved that 2 equals 1. Now, of course, looking at this, you know, 2 doesn't equal 1. There has to be a mistake here. I must be tricking you somehow. And the answer is, of course I am. But I think it's a good idea for you guys to pause the video and see if you can figure out the step that doesn't make sense, the step where we go incorrect. Okay, now that we're back, you might have noticed, and if not, that's fine. This is a very, very, very subtle thing. You might have noticed we canceled out this a minus b on both sides. But what does it mean when we cancel out a term on both sides of an equation like that? Well, it means we're dividing both sides by that. So what we're really doing is we're dividing both sides by a minus b. Okay, so what? Who cares? But remember, what did we start with? We started with a equals b. So if a equals b, what's a minus b? Well, a minus b must be 0. If they're the same number, if you subtract them, of course you're going to get 0. So what we really did here, we didn't divide by a minus b. Well, we did, but we really divided by a big old 0. And you can see if we divide by 0, well, we can make anything we like happen. In this case, we made 2 equals 1. So you can see why dividing by 0 is a problem. It makes untrue things appear to be true. If you're allowed to divide by 0, you get things like 2 equals 1. So I just want to quickly talk about why we can't in general. So why we can't divide by 0. And in fact, this is enough. Just the case that we can make 2 equals 1 if we divide by 0, that's enough to say that, well, we don't want to be able to divide by 0, we're not going to allow it. But I want to show you kind of in 2 cases. So let's consider a divided by 0, where, well, the first one, let's do case 1. Let's do where a isn't 0. So it's some whole number that isn't 0, some counting number, divided by 0. Well, let's pretend we can. So let's suppose, and this is kind of like a proof by contradiction, suppose that a divided by 0 actually has some answer c. And I will say I'm not going to deal with the remainder in this case. You can, it makes things a little more fiddly, but just to give you the idea, let's just say it equals some number c, where c is some, I don't know, whole number, I guess. Whatever. You could do it with a real number, but I'm just going to stick to whole numbers. It doesn't really matter. The idea is going to come across. Well, what does this mean? This would mean that a equals c times 0. Because remember, forget about the remainder. Assume that there's no remainder. I don't want to get into that fiddly bit, but assume there's no remainder. A divided by 0 equals c means that you should be able to write a as c groups of 0 with no remainder. Again, we're not going to worry about that. But what does this say? This says that the answer is going to be some number you can multiply by 0 to get a non-zero number, a. But we know c times 0, of course, equals 0 by the property of multiplying by 0. Since a doesn't equal 0, this can't happen. this in some sense is a contradiction. We're going to talk about contradictions a little bit later in the course, but I'll just leave it at that for now. There's no way that you can multiply any number by 0 to get something non-zero. And case 2, let's say maybe 0 divided by 0 makes sense. Let's check. Let's do 0 divided by 0. Well, again, let's suppose that 0 divided by 0 equals some c. Let me scroll just to give a little more room. Oh, there we go. What does this mean? This means we should be able to write 0 as 0 times, or let's do it c times 0 to keep the same form. 0 equals c times 0. And just to be clear, this is our dividend 0, and this is our divisor 0. Not that it really makes a difference. So, what number, when you multiply it by 0, do you get? 0. And of course the answer is any number you like. Why is that a problem? Pause the video now. See if you can think about why that's going to be a problem. Reread the definition for division for a little bit of guidance. Alright, now that we're back, you should notice that in the definition of division, this quotient here, we said it's unique, but here, any c will make this equation true, any number you like. So it's not unique, but this holds for every whole number that c could be. Thus, it is not unique, and I'll write it like this, but I'll say it, the quotient remainder theorem, QRT, is not satisfied, and that's no good. If we allow division by 0, well, that's going to be a big problem. And you can see from the examples above. So the first one said if we're allowed to divide by 0, then we can make 2 equal 1. And you can imagine how many problems that would cause. You can make anything equal anything that you like. And as kind of a more general example, well, for any number, if you allow division by 0, well, then our definition doesn't make sense. Either, well, there's just no number that satisfies it, in the case where a isn't 0, or every number satisfies it, in the case where a equals 0, when we're looking at 0 divided by 0. And either way, we don't get one unique answer.